Dear enthusiasts of discovery and innovation, get ready to embark on a captivating journey into the heart of electricity, that elusive force that has shaped our reality since its revelation. In this enchanting video, we invite you to join us for a breathtaking exploration through the ages, scientific and technological advancements that have woven the fabric of our understanding and utilization of electricity. Fasten your seatbelts, as we are about to delve deep into the intricacies of this natural power, pulsating to the rhythm of electrifying bursts of knowledge and revelation. Brace yourselves to be awestruck, for the realm of electricity continues to unveil its mysteries at every step of this extraordinary odyssey. In this first part, we journey back in time to antiquity, an era when the wonders of electricity were beginning to unfold, long before modern laboratories were illuminated by electric light. The Greeks, renowned for their advancements in philosophy and science, also laid the foundation for our understanding of electricity. Imagine yourself in the bustling streets of Athens, where curious minds of the time observed mysterious phenomena when rubbing amber against fur. This simple action generated astonishing energy, which, in the form of an electric spark, could attract small lightweight objects. These early electric sparks were like puzzles to be solved for thinkers of antiquity. Among these thinkers was Thales of Miletus, a Greek philosopher of the 6th century BCE. He was one of the first to document the electrical properties of amber, turning it into an intellectual curiosity. However, it would take many centuries before these initial sparks were fully understood and exploitable. The Greeks were not the only ones fascinated by these mysterious electric phenomena. In ancient China, it was discovered that electricity could be produced by rubbing bamboo sticks. These discoveries, though rudimentary, marked the first steps towards understanding this amazing natural force. Antiquity thus left behind a series of electric sparks, clues that would guide the innovative minds of centuries to come. The simple curiosity of the Greeks and other ancient cultures would serve as the foundation for a scientific quest that would radically transform the modern world through electricity. Join us as we delve deeper into this exciting history, exploring the major milestones that led to the electric revolution. In the heart of the 18th century, as the Enlightenment illuminated minds with new ideas and a thirst for knowledge, a daring man would push the boundaries of human understanding of electricity. This visionary was none other than Benjamin Franklin, an American polymath whose contributions to science and philosophy stand the test of time. Franklin was much more than a statesman and a renowned writer. He was a curious explorer, willing to challenge the elements to unravel the mysteries of electricity. One of his most famous and audacious experiments involved using kites to prove the connection between lightning and electricity. Imagine the captivating image of Franklin firmly holding a kite, his eyes scanning the sky for answers. Equipped with a key attached to the kite string and a metal conductor, Franklin patiently waited for the elements to cooperate. And then, the decisive moment arrived, an electric spark surged forth and struck the key, confirming the electric nature of lightning. This bold experiment was not just a spectacular demonstration of electricity, it also paved the way for a deeper understanding of its mechanisms. Franklin's work laid the foundation for the theory of electricity, contributing to the advancement of electrical sciences and the emergence of revolutionary technologies. Through his experiments and insatiable curiosity, Benjamin Franklin bequeathed to humanity a valuable understanding of electricity. His determination to explore the unknown and put innovative ideas into practice set the stage for the upcoming electric revolution. As we continue our journey through electrifying history, Let us keep in mind the intrepid pioneer spirit that enabled Franklin to capture the spark of electrical knowledge. As humanity immersed itself in the Industrial Revolution, an era of unprecedented scientific discoveries began to illuminate the realms of electricity and magnetism. Brilliant minds of the 19th century embarked on a quest to unravel the mysteries of electricity and magnetism, thus laying the foundations for our modern understanding of electromagnetism. Among these visionary researchers, two names stand out prominently: Michael Faraday and Andre-Marie Ampere. These individuals devoted their lives to exploring the profound connections between electricity and magnetism, ushering in a new era of scientific understanding. Michael Faraday, a self-taught British scientist, was one of the first to delve into the interaction between electricity and magnetism. His experiments with magnetic and electric fields led to the formulation of the laws of electromagnetism, which established the fundamental rules governing electrical and magnetic phenomena. His crucial concept of lines of force allowed for the visualization and description of the intricate interactions between these seemingly distinct forces. On the other side of the English Channel, in France, Andre-Marie Ampere was also delving into the mysteries of electromagnetism. Ampere formulated one of the earliest mathematical theories of electromagnetism, connecting electric currents to magnetic fields. His work laid the groundwork for Ampere's law, which describes how electric currents create magnetic fields and vice versa. This groundbreaking discovery paved the way for a deeper understanding of the relationship between electricity and magnetism. The contributions of Faraday and Ampere extended beyond theory. They conducted innovative experiments that demonstrated the existence of electromagnet forces and created practical devices such as electric motors and generators. These advancements formed the basis for many modern technologies, from electric lighting to communication systems and transportation. By exploring the works of Faraday and Ampere, we unearth the very foundations of electromagnetism, a discovery that profoundly influenced our modern world. Their innovative ideas paved the path for technological breakthroughs that would forever alter the way we interact with electricity and magnetism. Join us as we continue to traverse the conduits of electrical science, delving into currents of discoveries that illuminated the path toward the modern electromagnetic era. As we delve into the depths of the history of electricity, another name shines brightly: Alessandro Volta, a creative and ingenious mind who made a monumental contribution to our understanding of electricity. His bold innovation, the creation of the first voltaic pile, would revolutionize how we generate and use electricity. Alessandro Volta was an 18th-century Italian scientist whose passion for electrical experiments led to a discovery that would change the face of science and technology. Drawing inspiration from the works of his predecessors, Volta devised a groundbreaking apparatus that forever transformed our ability to generate a continuous electric current. Imagine a device composed of alternating stacks of metal discs with discs made of conducting material, such as zinc and copper. Each pair of discs was separated by a conducting material soaked in a saline solution, forming a voltaic element. When these elements were stacked, they generated a steady flow of electricity, giving rise to the first voltaic pile, also known as the voltaic cell. The voltaic pile was a revolutionary advancement because it enabled the generation of a continuous electric current, unlike previous electrostatic experiments that produced single discharges. This fundamental discovery paved the way for practical applications of electricity, fueling the development of new technologies. Indeed, the voltaic pile quickly found applications in various fields, from lighting to the stimulation of muscles and nerves for medical purposes. It also laid the groundwork for the subsequent development of rechargeable batteries, which revolutionized the portability of energy and powered a multitude of electrical devices. The invention of the voltaic pile by Alessandro Volta marks a crucial milestone in the history of electricity, transforming our capacity to generate and utilize electrical energy continuously. His ingenuity opened the door to a new era of discoveries and innovations, propelling humanity toward new electrical horizons. Join us as we explore the ramifications of this dazzling discovery and dive deeper into the ever-evolving electrical realm. As electricity continued to unveil its mysteries, a visionary inventor emerged to shape the technological and social landscape in unimaginable ways. This subpart takes us through time to the era of electric light, as Thomas Edison, one of the greatest inventors of all time, embarked on a daring quest to perfect the electric bulb, thus illuminating the future of energy. Thomas Alva Edison, often dubbed the Wizard of Menlo Park, had an insatiable thirst for discovery and innovation. He was well aware of electricity's potential to revolutionize the world, but he quickly realized that mastering artificial light creation was crucial. In an era when illumination primarily relied on natural light sources, the idea of lighting up the darkness with electricity was a revolution in itself. Edison tirelessly experimented to find the perfect filament that would enable the creation of a durable and efficient electric bulb. His laboratories in Menlo Park, New Jersey, became the cradle of innovation, where he tested thousands of materials and configurations. After countless trials and errors, Edison eventually discovered that the carbon filament was the ideal candidate, capable of shining brightly without quickly burning out. In 1879, after months of relentless effort, Edison's electric bulb glowed for the first time, illuminating the night with a warm and comforting glow. This achievement marked the beginning of a new era, the era of electric lighting. Streets, homes, and factories were soon flooded with artificial light, radically transforming how people lived and worked. The impact of Edison's electric bulb cannot be underestimated. It not only provided a practical solution to a fundamental need, but also triggered an economic and social revolution. Businesses now operated day and night, cities were aglow with light, and the very notion of time was transformed. Electricity had found a revolutionary application that would serve as the foundation for even greater technological advancements. The story of Thomas Edison and his electric bulb is a captivating example of how an innovative idea can illuminate paths of innovation. Join us as we dive into Edison's exciting journey toward electric lighting and discover how this extraordinary invention illuminated the path to the electrifying future that awaited us. In the heart of the burgeoning electric era, a captivating and fierce rivalry unfolded, featuring two giants of science and innovation, Thomas Edison and Nikola Tesla. This subpart takes us into the whirlwind of the War of the Currents, an epic conflict that shaped the landscape of electricity and revealed critical economic and scientific stakes of the time. Edison's electric bulb had opened a gateway to a bright future, but it was just the beginning of a much larger electrical revolution. However, a fundamental question arose: which electrical system would dominate the world? Two radically different visions emerged, embodied by Edison and Tesla. Edison championed direct current, DC, a method of transmitting electricity in which the electric current flows steadily in one direction. His system was already widely implemented and considered safe for domestic applications, but it was limited in terms of transmission distance. On the other hand, visionary genius Nikola Tesla advocated for alternating current, AC, in which the current changes direction at regular intervals. Tesla had demonstrated that AC allowed for electricity transmission over long distances with fewer losses, thus opening the possibility of large-scale energy distribution. However, AC was seen as more dangerous than DC for domestic applications. The rivalry between Edison and Tesla went beyond technical considerations. It was also fueled by significant economic stakes. Edison, with the financial support of his associate J.P. Morgan, had established a strong infrastructure based on DC and was determined to preserve it. Tesla, on the other hand, was backed by George Westinghouse, who firmly believed in the potential of AC. The battle for dominance in the electricity market reached its climax during the War of the Currents, a series of public debates, newspaper articles, and experiments aimed at proving the superiority of either DC or AC. Ultimately, thanks to Tesla's successful demonstration of AC electricity transmission over long distances at Niagara Falls, alternating current emerged victorious. The triumph of alternating current marked a major turning point in the history of electricity, paving the way for larger electrical networks and widespread energy distribution. The War of the Currents not only revealed the advantages of alternating current but also highlighted the economic and scientific dynamics that influence technological development. As we delve into this captivating episode of electrical history, we uncover the passionate protagonists who shaped our modern use of electricity and the profound implications of their choices. Join us as we illuminate the crucial stakes of the War of the Currents and prepare to plunge into the uncharted waters of the next electric era. As the 20th century took flight, electricity emerged as a powerful and ubiquitous force, poised to redefine every aspect of human life. In this subpart, let's delve into the exciting period of society's electrification, where electric currents ushered in radical changes in homes, industries, and transportation, leaving an indelible mark on our modern way of life. The advent of electricity marked a fundamental shift in how we illuminated our homes. Gas lamps and candles were relegated to the past, making way for electric lighting. Families could now enjoy the warm and constant glow of electric light, creating a new and welcoming atmosphere within their households. City streets were now adorned with electric lampposts, transforming the night into a time of activity and sociability. Yet, electrification did not stop at the threshold of homes. Industries were profoundly affected as well. Factories, once dim and cluttered, were now illuminated and equipped with electric machines, greatly boosting productivity. Assembly lines sped up, manufacturing processes became more efficient, and industries could meet growing demand through the power of electricity. Transportation also underwent a revolutionary transformation thanks to electricity. Electric locomotives began rumbling along railway tracks, offering a cleaner and quieter alternative to steam locomotives. Electric trams invaded city streets, providing fast and convenient transportation for urban dwellers. Electricity even propelled the nascent aviation industry, contributing to the development of electric aircraft. The electrification of society also gave birth to new household appliances, from refrigerators to washing machines, liberating households from tedious tasks and improving quality of life. Communications were revolutionized by the invention of the telephone and radio, paving the way for instant global connections. However, with these advancements also came the responsibility of managing large-scale electricity production and distribution. Electrical grids expanded, requiring complex coordination to ensure reliable and consistent supply. Production, transportation, and distribution infrastructures were established to meet the growing demand for electricity. As we uncover the intricacies of 20th century electrification, we realized the magnitude of transformations that redefined our lives. Electricity illuminated our homes, energized our industries, accelerated our transportation, and interconnected our worlds. As we reflect on the progress already made, we prepare to dive into the electric future, where emerging technologies and renewable energy sources shape a new electrifying era. Join us as we explore the past, present, and future of electricity, a force that has illuminated our path toward the modern age. As the 21st century takes flight, a new era of energy transformation is underway, driven by the digital revolution and the rise of renewable energies. In this subpart, we dive into contemporary developments that are reshaping the global energy landscape, exploring the rise of digital electronics and the exponential growth of renewable energy sources such as solar panels and wind turbines. The advent of digital electronics has opened a door to endless technological possibilities. Computers, smartphones, and electronic devices have become essential extensions of our daily lives. The increasingly smaller and more powerful microelectronic chips have revolutionized how we communicate, work, learn, and interact with the world. This digital revolution has been powered by vast amounts of electricity, propelling an era of unprecedented innovation. However, this digital revolution has also highlighted the need to rethink our energy supply. The expansion of data centers, the growing energy demand of electronic devices, and environmental concerns have prompted exploration of cleaner and more sustainable energy sources. This is where renewable energies come into play. Solar panels, which convert solar energy into electricity, have become more efficient and affordable over time. Wind turbines harness the power of the wind to generate energy, offering a renewable and environmentally friendly source of electricity. These technologies have transformed how we produce and consume electricity, providing an alternative to fossil fuel sources. The transition to renewable energies has also been supported by advances in energy storage, allowing for efficient management of production and demand fluctuations. Lithium-ion batteries, for example, have played a crucial role in storing solar and wind energy, making these energy sources more reliable and adaptable. The union of the digital revolution and renewable energies has created a convergence of innovation that is shaping the energy future of our planet. Smart grids, energy-efficient homes and buildings, and electric vehicles are just a few examples of this evolution. The technological advancements of this era have the potential to reduce greenhouse gas emissions, ensure cleaner and more affordable energy, and create a sustainable future for generations to come. As we explore contemporary developments, we witness an exciting fusion of the power of electricity, electronics, and renewable energy. Together, these forces are reshaping our energy world, illuminating a path toward a sustainable and promising future. Join us as we contemplate these remarkable advances and prepare to embrace the infinite possibilities on the electrical horizon. As we gaze upon the horizon of electricity, a world of astonishing possibilities unfurls before us, propelled by revolutionary emerging technologies. In this subpart, let us plunge into ongoing research in quantum electricity, superconductors, and other cutting-edge advancements that promise to radically transform our future utilization of electricity. Quantum electricity is an enthralling frontier of science, delving into the quantum properties of subatomic particles to create novel forms of electrical technology. Qubits, the fundamental units of quantum information, could revolutionize the field of computing, offering unparalleled processing capabilities that could solve complex problems at astonishing speeds. Researchers are also harnessing quantum phenomena to create more efficient and powerful electronic devices. Superconductors represent another transformative advancement poised to reshape the electricity landscape. Superconductors allow the flow of electricity without resistance, meaning electricity could be transported over long distances without energy loss. This property could revolutionize how we transmit and utilize electricity, paving the way for more efficient electric grids and advanced energy storage technologies. Nanotechnologies, robotics, and advanced materials also comprise the arsenal of emerging technologies that promise to revolutionize our electricity utilization. Innovative materials could enhance the efficiency of solar panels and batteries, while robotics could transform how we build and maintain our electrical infrastructure. As we venture into the era of quantum electricity and emerging technologies, we witness a future brimming with possibilities. These advancements may not only enhance the efficiency and sustainability of our electricity usage but also open new avenues for science, medicine, and communication. From the primal spark that captured the human spirit to the emerging technologies shaping our future, the history of electricity is an epic that has illuminated our world with knowledge and innovation. From the early explorers of static electricity to visionary minds that revolutionized electrical systems, each step of this journey has left an indelible mark on our society. As we turn the pages of this captivating narrative, one thing is certain: electricity will continue to drive progress and discovery. Current advances in energy storage, smart grids, quantum electricity, and other emerging technologies illuminate the path toward a cleaner, more efficient, and more innovative energy future. Stay connected, for electricity continues to shape our lives in fascinating and surprising ways. Stay abreast of our upcoming explorations, as the electrifying future that awaits us is only just beginning. Thank you for embarking on this thrilling odyssey through the electric current of history, science, and innovation. Keep marveling and exploring, for electricity is and will remain one of the most powerful and illuminating forces in our universe. Until the next electrifying adventure.